Ever wondered how large organizations manage their critical applications and data? The answer lies in a technology that's been around for decades: mainframes. Take a moment to imagine a high-performance computer, a powerhouse of processing and data management, designed to handle the critical operations of large organizations. That's what a mainframe system is. This technology, which has been a cornerstone of our computing infrastructure since the mid-20th century, is still remarkably relevant and indispensable in today's digital age. Mainframes are the unsung heroes in the world of technology, quietly running in the background, ensuring that our banks, hospitals, and governments function smoothly. When you swipe your credit card, when you check in for a flight, or even when you schedule a doctor's appointment, there's a good chance a mainframe is working behind the scenes. But what exactly is a mainframe? In simple terms, a mainframe is a large, powerful computer system capable of processing and managing vast amounts of data quickly and securely. These systems are designed to be reliable, secure, and scalable, making them ideal for large organizations that handle critical applications such as transaction processing, data management, and enterprise resource planning. Mainframes originated in the 1950s with the advent of early computing technology. Companies like IBM played a pivotal role in their development, introducing iconic mainframe models such as the IBM System 360. These systems were initially bulky, expensive, and operated using punch cards. However, over the years, mainframes have evolved to become more powerful, compact, and capable of supporting complex workloads. Today, mainframes are the backbone of many industries, from banking to healthcare. They handle millions of transactions each day, store and manage vast amounts of data, and ensure that our digital world keeps turning. Despite the rise of newer technologies like cloud computing, mainframes continue to hold their ground, thanks to their unparalleled reliability, scalability, and security. So, the next time you use an ATM, book a flight, or visit a doctor, remember the quiet mainframe working tirelessly in the background. Mainframes form the backbone of many industries, from banking to healthcare, and their importance cannot be overstated. Mainframes have a rich history dating back to the mid-20th century. It was during the vibrant 1950s that the concept of mainframes was born, a period that saw rapid advancements in technology. Early mainframes were colossal machines, taking up entire rooms, and relied on punch card systems to function. These punch cards were the predecessors of today's digital data storage and were quite literally the physical embodiment of data. IBM, a name synonymous with mainframes, played a critical role in their evolution. The company introduced the iconic IBM System 360 in the 1960s, which revolutionized the industry. It was a model of efficiency and power, a transformative leap from the room-sized computing behemoths of the past. It was also the world's first family of computers designed to cover the complete range of applications, from small to large, both commercial and scientific. But the journey of mainframes wasn't just about IBM. Other tech giants like Honeywell and Burroughs were also key players in this evolution, each contributing their unique innovations to the burgeoning field of mainframe technology. As the decades rolled on, mainframes began to shrink in physical size, but grew exponentially in terms of processing power and capabilities. By the 1980s and 1990s, mainframes had become integral to the operations of large organizations, supporting complex workloads and managing vast amounts of data with ease. They also started to shed their punch card skin, embracing the digital revolution with open arms. Fast forward to today, and mainframes are more advanced than ever. They're smaller, faster, and more powerful, capable of running a multitude of operations concurrently. They've evolved from being transaction processing machines to becoming the backbone of enterprise computing, supporting critical applications across various industries. From punch cards to modern-day digital systems, mainframes have come a long way. Their journey is a testament to the power of technological evolution and human ingenuity. And even after over 7 decades, mainframes continue to be a vital part of our digital infrastructure, proving their resilience and relevance in an ever-changing technological landscape. What sets mainframes apart is their unique architecture. Let's dive in and explore what that means. Mainframes are designed to handle enormous volumes of data and transactions with utmost reliability and security. To achieve this, they often use techniques such as symmetric multiprocessing or parallel processing. These methods allow mainframes to process multiple tasks simultaneously, leading to high throughput, or in simpler terms, a lot of work getting done in a short amount of time. But the architecture of these computing behemoths doesn't stop there. Mainframes also incorporate specialized hardware components. Redundant processors, memory modules, and input-output channels work in harmony to ensure fault tolerance and scalability. So, what does this mean? Well, fault tolerance is the ability of a system to continue functioning smoothly even if one or more components fail. Imagine if a single failure could bring down an entire banking system. Not a pleasant thought, right? That's why mainframes are constructed to be fault tolerant. Scalability, on the other hand, refers to the system's ability to handle increased workloads without compromising performance. In the world of mainframes, this means they can efficiently process the data of a few hundred users or scale up to handle the needs of millions of users, all without breaking a sweat. Let's put it this way. If mainframes were a building, their architecture would be like a skyscraper. The parallel processing would be the numerous elevators, moving people up and down simultaneously. The specialized hardware components would be the building's structural elements, like the beams and columns, ensuring it doesn't collapse under its own weight. Fault tolerance would be the backup systems, like emergency stairs and generators, ensuring the building functions even during a power outage. And scalability? That would be the ability to add more floors to accommodate more people as the need arises. In a nutshell, the architecture of mainframes is designed to deliver high performance, reliability, and scalability. It's this robust construction that allows them to support the critical applications and massive data requirements of today's industries. So, the next time you make a bank transaction or book a flight, remember, there's likely a mainframe working tirelessly in the background, all thanks to its remarkable architecture. The architecture of mainframes is designed to deliver high performance, reliability, and scalability. Mainframes run on specialized operating systems tailored to their needs. Now, what does that mean? Well, it's all about the software that controls the hardware, ensuring these powerful machines can perform at their peak. Let's take a closer look. One of the most common operating systems for mainframes is IBM's z/OS. It's a workhorse designed for high availability and scalability in transaction processing environments. It manages to juggle many balls at once, handling massive amounts of data without breaking a sweat. Then there's ZVM, another IBM creation. This one is all about virtualization, allowing multiple instances of the same or different operating systems to run concurrently on a single mainframe. It's like having several computers in one, maximizing efficiency and performance. And let's not forget ZVSE, a system that provides support for legacy applications on mainframe platforms. This means even older software can run smoothly on these modern machines, ensuring nothing gets left behind in the march of progress. But operating systems are just one part of the equation. These mainframes are packed with key features that make them stand out in the world of enterprise computing. Firstly, reliability. Mainframes are known for their fault tolerance, often boasting uptime levels of 99.999% or higher. That's a lot of nines. It means they're incredibly dependable, rarely experiencing downtime. Next, scalability. Mainframes can support massive workloads and millions of users concurrently. They can grow with a business, adapting to increasing demands without missing a beat. Then there's security. Mainframes incorporate robust security mechanisms, such as encryption, access controls, and auditing. This ensures sensitive data and transactions remain protected at all times. Compatibility is another key feature. Mainframes support a wide range of programming languages, databases, and legacy applications. This means organizations can leverage existing investments and skills, rather than starting from scratch, and of course, performance. Mainframes deliver exceptional speed for transaction processing, batch processing, and real-time analytics. Their optimized architecture and hardware ensure they're always at the top of their game. Mainframes offer a host of features that make them ideal for enterprise computing. They're reliable, scalable, secure, and compatible, making them an invaluable tool in the modern business landscape. Mainframes are widely used across various industries. Their unique capabilities make them the heart of many critical operations. Let's delve into how different sectors put these powerful systems to use. In the financial services sector, mainframes are the workhorses behind the scenes. Banks, insurance companies, and stock exchanges rely on them to process millions of transactions every day. Imagine every time you swipe your credit card, transfer money, or make an insurance claim. These actions often engage mainframe systems, which ensure these transactions are executed securely and efficiently. Government agencies also depend heavily on mainframes. These systems handle a variety of citizen services, from tax processing to benefits administration. For instance, when you file your taxes, mainframes are there, churning through mountains of data to calculate your dues or rebates. They offer the reliability and security necessary for dealing with such sensitive information. Healthcare is another field where mainframes play a pivotal role. Hospitals and healthcare providers use them to manage electronic health records, billing systems, and clinical databases. When a doctor pulls up your medical history, or when a pharmacist verifies your prescription, it's a mainframe working in the background, ensuring the right information is available at the right time. Airlines, too, lean on mainframes for everything from managing reservations and flight scheduling to crew assignments. Next time you book a flight or check in for your journey, remember that a mainframe is likely making your travel plans a reality. As we've seen, mainframes are not relics of a bygone era but remain integral to many modern industries. Their reliability, performance, and security make them indispensable for handling large-scale mission-critical applications. From banking transactions to flight scheduling, mainframes play a crucial role in our daily lives. Whether we realize it or not, these systems touch nearly every aspect of our digital existence. To conclude, mainframes are a testament to the enduring power of technology. From their inception in the mid-20th century to the present day, they've evolved dramatically, yet their core purpose remains unchanged. They offer unparalleled reliability, scalability, security, and performance. They are crucial in various industries, handling massive workloads and ensuring smooth operations. Despite the rise of new technologies, mainframes continue to hold their ground, powering critical applications and data management for organizations worldwide.